Yes, hello students. In the today's lecture, we shall discuss one topic, that is load equalization, and this is required in the case the load is fluctuating type. For example, if you have a pressing machine, electric hammers, reciprocating pumps, etc., where the load comes only for short interval of time, and that is followed by a low load interval like this. So during this interval, the duty period, you can say, the load is high, the motor has to supply the torque, and after that, for brief interval, the load is not there, so the motor has to produce very low torque. So the load torque requirement is like this: high during this period and followed by a low load period. So what is the problem with this type of fluctuating load? Suppose we are using a DC motor to supply the load. So you know that in DC motor the torque is proportional to current, armature current. So the current will also fluctuate in the same way. Source current will also be fluctuating in the same way. And if the source current is like this, and we have, for example, if we have source voltage like this, and across this various loads are connected like this, and we have this is our load. Suppose this is very high, so the current that is flowing through the line is like this. Now if the line has a resistance Rs, every line will have some resistance, line resistance, and if that resistance is high, the weak line is there, or your load that you are operating here is very high in magnitude, then the voltage drop across the line resistance will also increase when the current is high, and it will become low when the current is low. So the output voltage here, that is the, you may call it load voltage, this voltage may call it VL, load voltage, this will also fluctuate like this. During high current interval, voltage drop will be high, load current will be small, and when the current is low, this voltage drop reduces, the voltage will become high. So this will be like this. So load voltage will fluctuate, and this voltage is available across other loads also. So all the consumers which are connected to this line will be affected by this voltage variation. So this is intolerable and it should not be allowed. So what is the remedy? What we can do to reduce this effect and reduce this voltage fluctuation? For that, what you can think? You can think that somehow during the high load period, the torque requirement is reduced. That is, the motor has to produce lesser torque than what is demanded by the load, and during the low load period, the motor has to produce a higher torque than the torque demanded by the load. So if you are able to do that, you can reduce the voltage fluctuation. You can reduce the load fluctuations. Further, if you want, motor load should be like this, somewhat like this. Somehow you reduce the torque required by the motor to be less than the load torque, and the torque to be produced by the motor during off load period should be higher than the torque demand. If you are able to do that, then you can say that the load is equalized and the effect on the voltage will also be minimized. So how we can do with that? You just recall the basic torque equation that we discussed earlier. T minus TL, motor torque minus load torque, is equal to J d omega m over dt. That torque we call as dynamic torque dt. So T minus TL is equal to TD. Let us write this equation in different way. T equal to, take this TL on the right hand side, T equal to TL plus J d omega m over dt. Or you can say T equal to TL plus TD. Now, as you see, the dynamic torque depends on rate of change of speed. So whenever the speed is increasing, this term is positive, and whenever the speed is decreasing, this term is negative. So you know that the motor has a drooping characteristics. For example, if you are using a DC motor, then it is having the characteristic like this. DC motor or induction motor, in both cases, the characteristic is drooping in nature. That is, for this is speed, this is torque. So let us take a highly drooping characteristic like this. So for low load, that we call TLL here, this may be the speed. For high load, this may be the speed. So the speed of the motor for high load will be this, and for low load it will be like this. So this is the case. So this means that whenever you load the motor, before that the motor was on less load. When you load the motor speed will decrease to become omega mh. So during high load period, the speed of the motor will decrease. This means that j d omega m or dt will be less than 0, or you can say that t will be less than TL. T will be TL minus this quantity, dynamic torque. So this means that the dynamic torque supplies a part of the load torque, and you can say that motor has to produce TL minus the dynamic torque. So dynamic torque, if you say take it on this side, so T plus TD equal to TL. So dynamic torque actually helps the load. So a part of the load torque is supplied by the dynamic torque. What happens during the low load period? Now we have reduced the load, speed will change from this value to this value, it will increase. So when the load is low, speed will increase, the term j d omega m over dt will become positive. So T will be more than TL. Now this is positive, so T equal to TL plus this quantity. The motor has to produce a higher torque than demanded by the load. So this means that during this interval, the torque produced by the motor will be higher than the load torque, and during the high load period, the torque produced by the motor will be less than the load torque, as this part will be supplied by the dynamic torque. So now let us see how the curve will be like this. So during high load period, the speed of the motor decreases like this. When the load is reduced, the speed increases, and it will settle to the new value of a steady state if time is elapsed further. Again the load reduces, load increases, the speed starts decreasing. So what will be the shape of the dynamic torque? Dynamic torque, which is j d omega m over by dt. So in this interval, it is decreasing, negative. So dynamic torque is negative. So it is negative and it reduces. And after some time, if the speed settles to new steady state speed, it will become constant after that. It will become 0 after that. So this is the dynamic torque. And at this instant, speed starts increasing again. So dynamic torque becomes positive. It becomes like this. Again, dynamic torque will be there only when the speed changes. If the speed settles to constant value, it will move towards 0. So this is the dynamic torque produced by the system. Now let us see what happens to the load torque. Load torque is like this, TL, which is high during the load period and low during the no load period. So it is the case. Let us see what is the total torque that the motor has to produce. The total torque is TL plus TD. So the motor torque, you can say this is the load torque minus this TD. So you will get its value like this. Similarly, at this interval of time, this TL minus this TD, its small value here like this. So you can say that during this interval, the motor has to produce a torque like this. And again, you can see from here, TL plus TD. So at this point, you will get a torque like this. So in that way, you can see that if a dynamic torque was not present, then the motor would have to produce this torque. But because of dynamic torque, this is like this. So the fluctuation in the torque produced by the motor reduces, and that reduces the current drawn by the motor, and that causes reduction in fluctuation in the line voltage. So this is the case. In normal cases, the value of J is not very high, and this dynamic torque will not be so pronounced. It will be very small. So the load torque will be almost same as the motor torque, because the dynamic torque will be of negligible order. But here we have increased the dynamic torque. So you know that dynamic torque depends on J and d omega m over dt. The value of d omega m over dt will depend on the characteristic of the motor. If you take a motor of slightly more grouping characteristics, then this term will increase. So if you want to equalize the load, you have to choose a motor with a higher grouping characteristics. And number one. And number two, you have to increase the value of J. You have to increase the moment of inertia of the system. For that, what you can do? You can place flywheels on the motor shaft. On the motor shaft, you place some flywheels like this. You may have the flywheels like this. So, you know that the moment of inertia depends on mass multiplied by distance from the axis square, mr square. So, if you place the mass on the outer periphery of any rotating object, then the moment of inertia will increase. So here we place flywheels where most of the mass is concentrated at the periphery. That will increase the moment of inertia of the system. That will increase the dynamic torque. This will increase, and that will cause the motor torque to reduce, and it will have less fluctuation as compared to the case when J was small and dynamic torque was of negligible order. If dynamic torque is of negligible order, the motor torque is like this. If you have increased the value of J, enhanced the value of J to enhance the value of TD dynamic torque, then you will get a characteristics like this. In that way, you can reduce the fluctuation in the line current and the line voltage. So that is the remedy that you can apply in case where the loads are fluctuating in nature. So that is all for today's lecture. Thank you.